Hey everyone, and welcome. If you're gearing up for your ISTQB Certified Tester exam, you are in the perfect spot. My job here is to walk you through the absolute essentials you're going to be tested on. Today, we're building the foundation. We're talking about the core principles that every single professional software tester needs to know by heart. This is really where it all begins. But first, let's talk about why what we do matters so much. Picture this. June 4th, 1996. The brand new Ariane 5 rocket lifts off, and just 37 seconds later, it explodes. It just completely self-destructs. The cause wasn't a bad engine or fuel leak. No, it was a software bug. A simple thing, really. A 64-bit number trying to cram itself into a 16-bit space. And just like that, a decade of work and $500 million, poof, gone. This is the ultimate example of why the world needs skilled, professional testers. So, to prevent catastrophes like Ariane 5, we have to be absolutely crystal clear on what we're actually trying to do. It's not just about finding bugs. The real purpose of testing is, well, it's a lot bigger and more strategic than that. Okay, lean in for this one, because these are your core exam takeaways. Of course, a big part of our job is to check that the software does what it's supposed to do, that it meets all the requirements. But here's the part a lot of people miss. Testing actually prevents defects. We can find problems in the requirements docs themselves way before anyone writes a single line of code. Ultimately, our job is to lower risk, build confidence in the product, and give the people in charge the information they need to make the big calls, like, whether or not to launch the rocket. Now, if you're going to be a certified professional, you've got to speak the language. The ISTQB exam is definitely going to test you on these exact definitions, so let's make sure we nail them down right now. So, what is testing really? The official definition is that it's the whole process, planning, designing, and running tests, all with the goal of finding defects and checking the software's quality. But here is the single most important distinction you have to remember. Our job is to find and report the problems. We don't fix them. That's a totally different job. And that other job, it's called debugging. So when we find a failure and report it, a developer takes over. They're the ones who dive into the code, hunt down the root cause, figure it out, and then get rid of it. You could say testing finds the what, what's wrong, while debugging finds the why, and then does the how to fix it. This slide really breaks down that separation of powers, which, trust me, is a huge point of confusion for new testers. As testers, we often treat the software like a black box. We don't necessarily need to know how the engine works on the inside. We just need to know that when we press the gas pedal, the car goes. Developers, on the other hand, have to understand all the guts of the engine to find the problem and fix it. We prove a defect exists, they make it go away. It's also super important to get this chain of events straight. It all starts with a human making an error, like a developer misreading a requirement. That error then creates a defect, what we call a bug, inside the system. And then when the software runs that piece of code with the defect in it, that can cause a failure. That's the moment the system messes up. So remember, error leads to a defect, which can lead to a failure. Okay, so we know what testing is and what it isn't. But where do we testers fit into the grand scheme of things on a project? Well, we're a key part of a much larger discipline that's all about quality. Let's take a look at the hierarchy. Right at the very top, you've got quality management. Think of this as the giant umbrella that covers everything a company does to ensure quality. Now, under that umbrella, you've got two main pillars, quality assurance, or QA, and quality control, QC. And if you look closely, you'll see our world, testing, is a huge part of quality control. Let's just break that down a bit more. Quality assurance, QA, is all about being proactive. It's focused on the process. It's about making sure we're building the product the right way from the start to prevent defects from even happening. Quality control, on the other hand, is reactive. It's focused on the product itself. It's activities like testing that are designed to find any defects that slip through the cracks. So QA is prevention, QC is detection. All right, now we get to the heart of it. These 7 principles, they're basically the philosophy, the code that every professional tester lives by. Mastering these will completely change how you approach your job. And yeah, they're essential for your certification. Let's kick it off with principle number 1. This is, and I'm not exaggerating, probably the most important concept to get your head around, because it sets the right expectations for everyone on the team. And here it is. Testing shows the presence of defects, not their absence. No matter how many tests we run, we can never, ever prove a system is 100% bug-free. It's just not possible. Our job isn't to prove something is perfect, it's to find the flaws that are already there and reduce the risk of failure down to a level everyone is comfortable with. This is so critical for managing expectations. Now, that first principle leads us perfectly into the second one. If we can't prove there are no bugs, you might be wondering, well, why not? Because testing everything, and I mean everything, every possible input, every combination of clicks, every single path the user could take, it's basically impossible. Think of a simple enter your age field. You'd have to test every number, letters, symbols. It would take forever. That's why we have to use risk analysis and smart test techniques to focus our limited time on the areas that matter most. So we're going to jump ahead just a bit to principle number 4, because it builds so perfectly on this idea of focusing our efforts. Since we can't test everything, where should we be looking for all these bugs? Well, this is basically the Pareto principle in action, the 80-20 rule. What we've learned over decades is that defects aren't spread out evenly. They like to hang out together. They cluster in a few, usually very complex parts of the application. And you know what? That is fantastic news for us. It means we can use our skills to pinpoint these high-risk areas and aim our testing efforts right where they'll have the biggest impact. So, we've focused our testing on those risky areas. Awesome. But what happens when we run the same tests on those areas over and over and over again? Well, that brings us to principle number 5, a really cool concept that keeps every good tester on their toes. This is such a perfect analogy. It's called the pesticide paradox. Think about it. If you spray the same pesticide on a field year after year, the bugs eventually build up a resistance, right? Well, our tests are the same. If we run the exact same set of tests over and over, they stop being effective. They won't find any new bugs. The software is always changing, so our tests have to change too. We have to constantly review them, update them, and write new ones to keep finding new kinds of defects. Okay, for our last section, let's talk a little bit about psychology. See, being a great tester isn't just about the techniques you know. It's about how you think. It requires a totally different perspective.
Developers, and it's totally natural, have what's called a confirmation bias. They build something and they expect it to work. Their goal is to prove that it does work. Our mindset has to be the exact opposite. We have to come at it with curiosity, with a healthy dose of skepticism, and we have to actively search for the situations where the system might fail. We're not trying to break it, we're trying to discover where it's already broken.
And really, that's the bottom line. A developer's job is to construct a beautiful, strong building. A tester's job is to inspect that building and find the hidden cracks in the foundation before anyone moves in. It's a constructive, essential, and really critical role. So as you study for your exam and get ready for your career, really let that mindset sink in. Don't just learn the rules, learn how to think like a professional tester.